Hello. In this video, we're going to solve a quadratic equation using the quadratic formula. Any solutions that we get that are irrational, we're going to write those solutions as exact values in simplest radical form. So let's take a look at this. Anytime you're solving a quadratic equation using the quadratic formula, you first have to write the equation in the form ax squared plus bx plus c equals 0, so that you can use the quadratic formula. So to do that with this expression here, I think I'll start with that set of parentheses maybe. Start right here. Let's get rid of those parentheses. So to do that, we're going to use the distributive property. We'll FOIL that set of parentheses. We'll do first, outside, inside, last. So that I'm left with 7x squared plus 2 times x times x, that's going to be x squared, x times 12, and then negative 2 times x, that's going to be 12 minus 2 is 10, so it'll be plus 10x, and then minus 24 equals 61 minus 4x. I haven't messed with that right-hand side. Okay, so now that I've FOILed everything, I'm going to distribute this 2 that's on the outside to everything that's on the inside of those parentheses. So I've still got my 7x squared plus 2x squared plus 20x minus 48. All that equals 61 minus 4x. Okay, and it looks like we've got a couple of like terms on the left-hand side. Those two right there. We can actually add that 7x squared and that 2x squared. So we'll do that and we'll get 9x squared plus 20x minus 48. You can't simplify anything else on that left-hand side. Equals 61 minus 4x. Once I've combined all my like terms, what I'm going to do is I'm just going to move everything over to one side of the equation so that I can set it equal to 0. It doesn't matter which side of the equation you choose, as long as one of the sides equals 0. So I'm going to move these two terms over onto the left, just because it's moving 2 instead of moving 3, but it doesn't matter. To do that, I'm going to add the 4x on the right-hand side and add that same 4x on the left. And then I will subtract 61 from both sides. And the result is we'll have the 9x squared I didn't mess with. 20x plus 20 plus 4 is going to be 24x plus 24x. Minus 48 minus 61 is going to be negative 109. So minus 109. And now it's equal to 0. So once I have that expression equal to 0, then I can use the quadratic formula. I can identify my a, b, and c and plug all that stuff in. So in this case, your a value is going to be 9, your b value will be 24, and your c value is negative 109. Now you're just going to take those values and going to plug them into the quadratic formula. So I've got x equals negative b, which is 24, plus or minus the square root of b squared, which is 24 squared, minus 4 times a, which is 9, times c, which is negative 109. All divided by 2 times a, which is 9. Now I'm going to take all that values, and what I'm going to do now is I'm going to simplify everything that's underneath my square root all together, and then I'm going to simplify the stuff that's on the outside. I'm going to simplify each part of that formula in its own location. So I've got the x equals, we'll have the negative 24, plus or minus the square root of, let's see here, we got 24 squared minus 4 times 9 times negative 109 is 4,500. So I got the square root of 4,500, and 2 times 9 is 18. Okay, now that I have that formula simplified like that, I'm going to look at this square root. The square root of 4,500 is irrational. There is no perfect square. 4,500 is not a perfect square. So when I take the square root, it's going to be irrational. Because it's going to be irrational, I need to write that in simplest radical form. So to do that, I'm just going to use the prime factorization method. So we'll write the prime factorization of 4,500 over here on the side. It's going to be 1 and 4,500. Let's see, that's going to be, it's divisible by 2. 4,500 divided by 2. It's going to be 2250. Divisible by 2 again. That's going to be 1125. 1125 is no longer divisible by 2, but it is divisible by 3. So I'll put a 3 over here. That's 375. Divide that by, that's divisible by 3 again. It's going to be 3 and 125. That's no longer divisible by 3, but it is divisible by 5, which is 25. And then 25 is divisible by 5 again. And one more 5. There. So now that I have the prime factorization, that's going to be 2 squared times 3 squared times 5 cubed. I'll rewrite that in the original expression. So I've got 24 plus or minus the square root of 2 squared times 3 squared times 5 cubed, all divided by 18. Okay, so now I have one odd exponent there, so I'm going to split that up. So I've got negative 24 plus or minus the square root of 2 squared times 3 squared times 5 squared times 5. So I've still got 3 5s, just pulled one off to make all of my exponents even. And then any even exponents can come outside the square root, doing the simplest radical form. So I've got negative 24 plus or minus the square root. We're going to have, that's going to be 2 times 3 times 5 times the square root of 5. Because that 2 squared comes out as 2, the 3 squared comes out of the square root as 3, and the 5 squared comes out as 5. And then all of that's going to be divided by 18. Now I'm just going to simplify that so I've got one number instead of the prime factorization on the outside still. So I've got x equals negative 24 plus or minus 2 times 3 is 6 times 5 is 30. So I have 30 square roots of 5, all divided by 18. Okay, so now that I have the simplest radical form of the square root part of the quadratic formula, what I'm going to do is I'm going to look at these 3 numbers right here. And I'm going to be looking for the greatest common factor between 24, 30, and 18. Greatest common factor between 24, 30, and 18 is, they're divisible by 2, they're divisible by 3. 6? I think it's 6. So what we're going to do is we're going to divide each one of those numbers by 6. So I have x equals 24 divided by 6 is 4. So I got the negative 4. Plus or minus 30 divided by 6 is going to be 5. So you have 5 square roots of 5. And then 18 divided by 6 is going to be 3. And now there's nothing else I can simplify because that negative 4, that 5, and that 3 are relatively prime. They have no common divisors. So my final answer here is x equals negative 4 plus or minus 5 square roots of 5 divided by 3. That's it.